Okay.
Hi everyone, this is day one of eOTF second session, and thanks to OIP Labs Ramanujam for the collaboration, and we are committed to the connected intelligence going forward. And sorry, this looks like yeah, this is the one. So we have here OpenShift and sensor networks with Promateus, and Trinath was not able to join. However, he is one of our stalwarts from Hyderabad. Just to introduce him, he is currently working with F5, and he is working on the networking portion of it. And he has been there from the beginning of eOTF, at least 4 years back when he started his OTF. 4 to 5 years, I think, 5 years. And he is one of those community players who started with OP and FE, and is accomplished and product manager at F5. Then we have Digambar Patil, who has joined. He has a industry experience of 10 plus and 8 plus in the technical. This is 2 years back, I believe, but he is more than 12 now. He has broad knowledge about the OpenStack, and he was part of the Dell team for implementation of the bare metal along with Kubernetes. He was one of those early adopters of Kubernetes, and has done several projects, and also part of the team now currently at Microsoft, and he is an expert in Python, Go, and biggest. So before I go to the Digambar, the part which was presented by Trinath Somanchi, I just browse through quick. So what we have is a OpenShift is an enterprise Kubernetes platform, and you can build, deploy, and then scale and manage. That's the main theme behind this. And what one can do is we can just review what it is before we move. Yeah, here we go.
Want to propel your innovation cycle, improve customer experience, and gain competitive edge? Then you need agility with the way you build, deploy, manage, and scale software applications anywhere. To overcome the challenges of transforming legacy apps and develop new cloud-native apps, you need a Kubernetes-powered hybrid cloud application platform that can provide software developers, data scientists, and data engineers with self-service, secure access to their favorite development tools, frameworks, and data, and can handle any application in a consistent way across any location. Red Hat OpenShift is the Kubernetes-powered hybrid cloud application platform with capabilities to enable DevOps, giving you everything you need to quickly and securely build, deploy, manage, and scale any traditional or cloud-native application in a consistent way across any environment. Imagine being able to automatically deploy and update a database of your choice with the same ease as installing a smartphone application, or any of the app dev, AI, data analytics tooling, and more. OpenShift's deep integrations with our ecosystem partners and open source community projects using Kubernetes operators allows you to automate and simplify deployment, scaling, and lifecycle management of any workload in a consistent way across any cloud directly from within OpenShift, giving your teams more time and freedom to innovate faster. Red Hat Marketplace takes this one step further by helping simplify procurement and deployment of enterprise software on OpenShift anywhere. Red Hat Open Innovation Labs helps transform legacy apps and on-ramp new applications on OpenShift. Around the world, OpenShift is providing agility and empowering organizations to develop and run all kinds of applications. It's allowing manufacturers to be more productive. It's helping businesses to improve customer experiences. It's even enabling rapid detection of life-threatening conditions to save lives. Red Hat OpenShift is leading the way to a simpler, more consistent Kubernetes-powered hybrid cloud application platform, helping accelerate build, deploy, manage, and scale any application in a consistent way across hybrid clouds. The end result is faster innovation, improving customer experience, and gaining competitive edge. Learn more. Contact us today.
So we have seen enterprise Kubernetes platform, and generally Kubernetes platform is key for several projects, and most of the projects I would put it. But that's not the only option. There are several options, and many Linux distros are there which are supported, and so are Windows and all. So, or Azure, I would put it. So, what was interesting about Kubernetes from Trinath's point of view is on the F5 networking, because F5 is a load balancer company from Seattle, and they have been in this business for even before Kubernetes. And they have two major products. One is the NGINX, the what you call the web servers, which was a free available open source, and the other is obviously they have got their hardening on it. There is another product called Big IP, which is nothing but a what you call the box which is used for balancing, load balancing various workloads, and it uses some control language, and it works on the cluster, Kubernetes cluster. So those are the two main. Most of the work which Trinath has been pointing is working on this container network interface. Kubernetes as such as a container platform has a CNI requirement. That is, you need to have container network interface, which is standard to facilitate communication between the pods, and that is in the container. So container networking requires that. And so this can be done through various options like cluster IP, node port, host port, load balancer. These are the various ways to tweak the performance. So at the cluster level, so target cluster, Kubernetes itself comes with a master and which is a system cluster, and then you have the target cluster, which is a workload cluster. So usually they are in a cluster, and so a cluster where you create the pods and all can be accessed through host port, node port, and these are the concepts which are used. Plus, besides that, there is an ingress resource type which is useful for L7 content routing and all. So these are the things which are managed by the Big IP, as well as plus for the HTTP traffic, one uses the NGINX as per the F5 formula for success, and they have whatever called support for the drivers for the CNI like Flannel and Calico, using VXLAN and BGP, which are the protocols, and ingress service is what they use for automating with Big IP. So that's all as far as Kubernetes F5 portion of the NAT is there. Hope if you want more detail, you can connect to him. And with that, I will hand over to Digambar. Digambar, floor is yours.
Thanks, Prakash. Hello, everyone. It's nice to be here in this group, and so already Prakash give an introduction about me. So I will start on the topic itself because I don't have much time next 10 minutes time to join another call. So Promateus is a monitoring tool which Kubernetes uses across its all sub projects or in CNCF ecosystem. So it's a CNCF project, not Kubernetes, because CNCF has multiple projects and it is one of the world recognized one across the domains. So, why we need Matrix and everything? Because when this project came into picture, because we have pods, we have systems running, we have nodes running, and every system we need to know and trace if something fails, what it fails, if service going to get failed. So how do we know? Okay, and based on to generate, to get the alert, to get the query, to get the data and metrics, and based on that we do some calculations, and we post that to a Grafana or any other tool, uh, and we demonstrate that these are the things which we need to take care of, and this is how we are getting metrics. So there are push notification and pull notification. So how it works, in Kubernetes, there are multiple pods or nodes where we annotate, though we annotate, add annotation, Prometheus annotation. That's how the service exposed to the outside. So for that we have to use the exporters. Okay, so what exporter does? Okay, exporter actually listens on the port and pull the metrics of that service. Okay, and each exporter is responsible for each project. Let's say we have a kubeword, so kubeword exporter is needed. We have a node, so node exporter is needed. So whatever the matrix you want to pull from respective project or whichever the project, we need to add exporter. Otherwise you only installing Prometheus doesn't work. So Prometheus is kind of exposing those matrix to the web or any other UI. So, but we have to, these are the exporters which actually taking care of talking to the service and pushing those data to them via Prometheus. Okay, so in the future we will have telegraphs and other things will come into picture, but that's how it works. Okay, so so there is a jobs and exporter you see, and Prometheus server which is exposing data to the UI, and here you can see the server which has storage, PromSQL. PromSQL is a kind of query language which is used to display and query the data from the server. So let's say I want to pull the data from keyword matrix related to VMI and others. So we will use PromQL, and we will display all the data. Let's say we want to display query the node matrix. So we will query those into the QL. So PromQL has insights, pod kind of queries. So you can respective container queries and all those. It is defined by containers. It is actually those things whichever the query language provides. So query language is nothing but SQL kind of thing. So kind of SQL is also a query language where we have tags, sections, and sessions and other things which we can use, and then query the data from the database. Okay, so where those data is stored, so PromSQL uses its own persistent DB or other things, databases where this data is stored, and retrieval happen through the exporters and PromQL servers. So once the PromQL data gets the data, that query data will be populated into a dashboard. Either it's a prom dashboard, Grafana, or web UI. So wherever we use from Grafana, we also do those queries from some Grafana languages there also. So from there we can pull the data and put it on the Grafana, or we can have our own dashboard. So this is a matrix where we are displaying in Grafana. But where are the alerts? Because alerts are the things which people get notification via email, via alerting tools like dashboard. You will see the alerts. So those alerts will be displayed. Let's say I want to configure the alert where the threshold I want to set, and that threshold is actually whenever we go and hit the threshold, so server hit, or that one of the service hit that process that threshold, it will get query that threshold that alert is generated and pushed to the email notification created and updated to the user. This is kind of automatic thing happens because in case of Matrix, we usually don't see, because if you go and particularly see on the database, sorry, on the Grafana or UI, then and then only you will get to know. But in case of alerts, people get notifications automatically. That's kind of push notification it does. Okay, so so these are the things I see, which is Prometheus is making more or bringing more logic and more usefulness in the Kubernetes, so that it is a widely used across all the services, all the projects, and it is one of the project which is used horizontally across all the vertical domains. So I think that's a short introduction I can say here. And you can see here that there is a Linux VM, MySQL, C groups. These are kind of a northbound, southbound things we use here, and the northbound is API server, web apps, which kind of pods and other things which is used. But you can see that Prometheus is actually used across all these southbound or east picture, which southbound or northbound is, and the service discovery it does against DNS and console and AWS. But in case of copy, we have multiple cluster providers, and we need to add annotations so that those providers should also expose. But based on the cloud providers, it is supported. Currently, I didn't get chance how it work in case of copy, but I believe that when we annotate those things and have an exporter for those, I think it should work across all the copy providers. I think that's it from my side. Maybe next time I'll give more in detail introduction about how to develop a node exporter or custom Prometheus exporter, how we can use it, how we can ship it, and how it will be displayed data on across all, pull the data from this Kubernetes. So in a development environment, maybe that can be covered next time. So that's it from my side. I'll over to Prakash.
Hey, thank you, Digambar, for the quick this one. One mention I forgot to is TSDB, that is the time series database is used and numerical data is collected. And if you want something long term or accurate, then you must use a Zabbix like thing rather than Prometheus. So this is one of the takeaways from this, and hopefully this is what we have for this session. We'll move on to the next session. And thank you, Digambar. We will those who participate get the certificate, and so obviously we'll send you the one. And thank you for taking time off. And hopefully next time we will bring something on Azure too. Thanks.
Sure.
We'll move on to the next topic, and let me come to the next topic. So, do you want to, who does session 3? Do we continue with me, or Vipin, you want to take? Vipin, Shubham, or should it be Prakash Parth? Parth, are you ready?
Yeah. You guys can do it. Like,
yeah. So,
third session.
okay. So, okay, I'll start with the, sorry, the third one. Just a second. Okay. Session 3 we get into. Before that, let me just, close the, stop the session, and let me just stop the recording. Hi everyone. So let me start. This is again session 3 in the sequence of connected intelligence of the eOTF meetup online one day today, 15 July. And thanks to OIP Lab Ramanujan College for collaboration. And in this, first let me talk about the speaker one, and Parth. Parth Yadav is a research associate and doing his MTech at RCD, and he is Yeah, I'll just introduce you. Hey, thanks for.
Prakash, hi Prakash, can you share your screen?
Yeah, okay. I have not shared the screen. Okay. Thank you for. Hi, everyone. Parth, I'm introducing Parth. Uh, he is a research associate at Ramanujan College, Delhi, and a Kubernetes expert and PTL for Distro Kubernetes stack. He himself is personally evolving to next generation cloud computing technology, doing his MTech now, and he is the brain behind the project OpenStack. Currently executing data center multiple open source projects like Annotate besides OpenStack, doing his masters as indicated earlier at Delhi University, and some time dedicated for search for innovation. He is looking always for innovations. He is a very excellent person and a humble guy, and most of the people he has helped in OTF for the hackathon previously, and has been part of working with Vipin for long, and we really want to recognize him. Uh, hope he is back to normal. He had some health issues earlier, and we look forward to his participation in the future. Second, uh, before I move, uh, is it not moving? Yeah. Okay. Myself, Prakash, I'm the co-founder, secretary. You heard enough of me, but to just iterate, I'm MTech Electrical Communication. Was to be working for Open Infra as a board of director and currently on the boards of eOTF. And we'll have more sessions as we talk about myself. Next. So with this, I will hand over to uh, Parth. Parth, take it. It's yours. I will move the slides as you want. Parth, are you there?
Yeah, or I can, or else I can share.
Yeah, you can share also. Do you want to share? Then in that case, I'll stop sharing.
Yeah.
Just a second. I'll stop sharing and then share. You are co-host, right? Yeah, so you can share. Yeah, go ahead.
Yeah. So is it visible?
Yeah, it is visible. Go ahead and can.
Okay, so the today's talk, the topic is scripting stack, and it's gonna be very short. We'll be covering what is scripting stack and how it looks like to use, its benefits. We'll just have a look possible use case with Nephio, and at the end we will look at OpenStack Helm, which we have worked with along with OpenStack for last 6 months. Uh, so first of all, what is OpenStack? Uh, Kub- OpenStack is our Kubernetes native OpenStack, or you can say it's a Kubernetes add-on that allows users to use OpenStack from Kubernetes command line. Uh, that is kubectl. OpenStack is formed from two words, joining two words, Kubernetes and OpenStack, hence forming OpenStack. So initially, how it started was I wrote a paper along with my mentor Vipin Rajeswam, uh, which you can see on the right. So the initial idea of OpenStack was what would cloud native OpenStack look like? So if today we want to build a cloud native OpenStack without changing a single line of OpenStack, then how we can achieve it. So that is what the this paper covered, and we presented a technology called OpenStack, which work as a small cloud native layer which sits between OpenStack and Kubernetes and builds cloud native operations and orchestrations for OpenStack resources and OpenStack cluster. So this is a diagram from that paper itself. It's an old diagram with some initial vision that we had. So here, first of all, we want to clarify that OpenStack is not making changes to Kubernetes or OpenStack in any way. So it's deployed alongside with these two toolings. So we have our physical infrastructure at the bottom, and top of it, we have formed our Kubernetes cluster. So, on this Kubernetes cluster, we have deployed OpenStack. And now what we get is we get two kinds of features from OpenStack. One is it can deploy and manage OpenStack cluster itself, which is represented by this code line. And the second thing is it can deploy and manage OpenStack resources like VM, router, subnet, and so on, which is represented by dotted lines. Um, so from the user point of view, a user can be on the left hand side or here and can provide deployment manifest of VM, subnet, etc. in form of YAML files as a declarative intent using kubectl tool to Kubernetes cluster. So these are some CR custom resources which are defined by OpenStack using CRD in the cluster. So OpenStack keeps looking for such custom resources, and when it sees any new desired resource and any new custom resource, it sees the desired state of that resource, and then its controllers tries to reconcile uh, the desire the actual state towards the desired state. So the dotted line you can see here, these are open HTTP endpoints that OpenStack provides, through which OpenStack is talking. And second thing that OpenStack provides is a self-managed OpenStack, self-provisioned, self-managed OpenStack cluster in form of containerized OpenStack on top of Kubernetes. So this is the flow that represents that how OpenStack can manage OpenStack cluster itself, whereas user only has to provide the desired state of the OpenStack cluster. Now, this was the initial idea with which the paper was written. It was not the actual implementation. So looking forward, we went forward with it and we launched our open source project with the same vision called OpenStack, which is hosted on GitHub, github.com/OpenStack. So in simple words, if you are a Kubernetes user, in simple words, if I want to tell you like what is OpenStack doing, then it's providing you a bunch of CRDs, and which allows you to deploy your OpenStack resources using kubectl utility. So you can write kubectl apply -f vm.yaml, and it will get deployed on the Kubernetes cluster. And then OpenStack takes the responsibility of creating this VM by talking to underlying OpenStack cluster. And we can see that on same Kubernetes cluster, we get our Kubernetes pod as well as we get our OpenStack virtual machines as well. There's some voice echo. If someone can. Okay. So yeah. So this is how it looks like now. Moving forward, what benefit we get with all this thing is like with OpenStack is we get first of all, the first benefit is we get a unified control plane. So we can manage Kubernetes resources as well as OpenStack resources from a single control plane using our kubectl utility. So this is the first benefit we get is single control plane for management of both k8s based and OSK based workloads. Second benefit is that since we are using a single utility kubectl, our learning curve has also reduced. Now users only need to understand Kubernetes and its working, and they can just carry on upgrade themselves with CRDs of OpenStacks and quickly start using OpenStack. So the learning curve has decreased. So now you do not have to go and learn how Horizon works and other OpenStack control CTL utilities works. So the second benefit is there's a reduced learning curve we get. The third benefit is that we get a cloud native OpenStack. So we get so OpenStack controllers form a cloud native layer which which provides cloud native operations for OpenStack resources. So as a user, I'm just deploying a resource on the Kubernetes cluster, and now I don't have to worry about it. And all those cloud native values are built using cloud native operations on top of OpenStack APIs using KubeStack. Uh, so and the third benefit is that since now we can use OpenStack through kubectl, we can take benefits of other Kubernetes utilities like and customize Argo and so on. So our project. So this is also again there's a reduced learning curve. We are using the same stack for our code maintenance, while we can use OpenStack and Kubernetes together. So now Nephio, as of today, 15th of July 2022, Nephio is in early stage, and we don't have any code, or we don't know how Nephio will look like at the end of 2022 or beginning of 2023. But as the diagram is proposed by the Nephio project, there are three things that it's trying to achieve. The first one is automating the cloud infra resources, whether it's on public cloud or private cloud. So provisioning of these infra resources. Then second thing it is trying to achieve is the automation of the network function workloads, and the third is configuration of this network function workloads. So if you look at the first goal, one of the first goal of the Nephio project, which is automating cloud infra resources on targeted public cloud or private cloud. We can see it is going to use CRDs for it. So what OpenStack can provide is in case of OpenStack private cloud, it can provide its CRDs to Nephio project for automating the provisioning of infra resources like VMs and routers for Nephio project, so that Nephio project do not have to reinvent the wheel. But it depends on the future. Right now, the picture is not clear. This is one possible use case where OpenStack can fit with Nephio. So yeah, at the southbound of Nephio. Now, if we talk about the progress on OpenStack, so OpenStack has not got much progress in last 1 year. So last 6 to 8 months have been invested on working with deploying OpenStack so that OpenStack can achieve a self-provisioning OpenStack cluster on top of Kubernetes in form of containerized OpenStack. So there's a project called OpenStack Handling Open Infra Foundation, which provides in charge to deploy OpenStack. What OpenStack has been doing is it is, rather than reinventing the wheel and containerizing and deploying its own version of OpenStack, it's trying to take OpenStack as a standard for deploying OpenStack. So there is no vendor lock-in like situation, like people who are supporting OpenStack and can easily integrate their OpenStack containerized version of OpenStack and with OpenStack. So what we saw was that we were able to achieve this. We were able to automate this successfully. But over 6 months, we saw that OpenStack Hand project develops on master branch, and it keeps changing again and again. And this was the fallback for us, that every week and after we see some new work setting OpenStack and which
Parth, we lost you.
Parth, we lost you. You were talking about the fallback. If you are back, please. start on it.
Okay, meanwhile, Prakash, I think you can continue.
Yeah, you can continue.
Yeah, Prakash, can you unmute yourself, Prakash?
Sorry. Yeah, on behalf of OpenStack team and PTL, that is Parth, who just got dropped off, I seek call for participation in community for OpenStack. And since we'll be tying it to Nephio, I believe there is a opportunity to learn on the leading edge. And we invite everybody who is here to help us get more people for OpenStack. With that, I'll move on to the next topic, and which is Nephio. So Nephio is some Greek term, I believe. I was told by the Google team, which is leading this. They are funding this for a 1-year agenda. And Nephio, what is Nephio before we get into? It is more to do with the 5G use cases. That's what I would say at this time. It's a middleware. So Nephio is a middleware which works on Kubernetes cluster. And that's why we can tie it to OpenStack. Like OpenStack was tied to OpenStack, it can be Nephio, you can call it, or you can continue with OpenStack name and try to introduce Nephio. So now let's get into Nephio. This is a Linux Foundation and Google Cloud project. Google Cloud, along with the Google Cloud, this was launched. Kandan Kadirvel, or colleague from earlier team of our eOTF, he has been the leader in this. He was also part of board of directors from AT&T prior year along with me. Currently, of course, Vipin is the representative, the board of directors at Open Infra. So Nephio is a project which is connecting Linux Foundation and Google Cloud, and it's just a cloud native automation for telecom networks. So we will talk about the TSPs and the CSPs, cloud service provider, telecom service provider, and network equipment providers. These are the three major participants. There are around 5 telco providers, around 5 to 6 network equipment, and several cloud service providers. So around 20 people are there, and this project is Linux Foundation led, and it started just on May 3rd as it was announced. So it's very recent. And why is this Nephio, and what does it do? So Nephio is a middleware. Now what does it do? So the cloud native implementation are evolving, and there are pain points in that. And so one of them is obviously cost, performance, optimization, operational efficiency, agility, and time to market. All these are lacking, and that need to be addressed. And so Nephio's goal is to address that part of it. Now, obviously, everything has to be declarative. That is the requirement, because you can't handle the non-declarative configurations, etc. And plus, okay, so I think I forgot to record, I believe. Okay, that's, can I just interrupt and see if I have recording? 1 sec.
Yes, it's recording.
Oh gosh, okay, sorry. So I'll go back again to my
But we can't
lecture.
see your screen if you are sharing your screen.
Okay, let me just share here. Share. Yeah, I will re-record just to clear. Nephio is a middleware which uses Kubernetes, and we started with earlier presentation on KubeStack, and so KubeStack can be used for Nephio middleware. And the architecture here is, yeah, so it's a Linux Foundation project recently funded by Google for a year. Started on May 3rd, and there are around 20 members, and still the TSC formation is not over. So majority of these participants are cloud service provider, telecom service provider, and network equipment providers who have a stake in cloud native implementation of telco services. So as we said, we have the journey has started on the cloud native, but it is evolving. It has relationship to what we need to do today, in the sense that we are moving from VNF to CNF, and as physical network functions are being implemented in 5G use cases, but that needs to be converted to container and not just VNFs. So the cloud native way of implementation requires special interfaces and images and creation and various other things. So the industry is looking forward to faster, simpler, and easier work for achieving optimization and agility. And the best practices in computer science, which is normally modularity, abstraction, separation of concerns, resource sharing, and loose coupling. So these are the 5 guiding principles of Nephio to simplify the cloud native deployment. So you can see that I spoke about these 3 network. So these CSP, TSP, and NEPs, they generally take the network function from vendors and communication service from providers and deploy it on the hyperscalers. So if you look at cloud native principles, there are 12 of them. We call it as 12 factor. And those are the 12 factor best practices. And that includes, like, you start with compatibility and then use the k8s distro, then you make it scalable, vertical and horizontal. Then you configure using the open configure CRDs or operators, as earlier mentioned by Parth. So you have to look at the observability, and Promateus we covered previously, and that is one of the ways to get the time series data base for the KPI and resilience of the platform. Then for portability, you need to make sure the applications are written in descriptive with the descriptors, declarative descriptor, and obviously the pain point is always the network and network abstraction, because CNI is hardware dependent. So how to make it abstract independent of CNI is one of the key premises of portability for the Nephio. Then that is where Parth mentioned to you in the Nephio previously, saying that you need to look at routers and switches which we can interface using the KubeStack. So that's a good area for us to look at. Then you have got, obviously, as a DevOps principle, it should be installable and upgradable to be able to maintain multiple versions on the production side. And then CI/CD across the platform, because you need to have what you call the parity of development deploying in the similar way. So similarity, and that is why you need a continuous integration and continuous deployment. And it should be open as a service. That means you should be able to get the RESTful API. That is where the cloud platforms each need to provide a RESTful API to be able to absorb, which is common across, like onboarding of VNF or CNF. Then it should be traceable telemetry, as we had seen the Digambar pointing out to the telemetry of Grafana and other tracing mechanism with CNC for open trace, open telemetry, etc. It should be loggable, like a lot of people use Splunk or some of those logging tools, and those are open telemetry also provides that. And the CSPs definitely want that it should be experience should be quality of experience, quality of service should be better with CNF and Kubernetes. So these are the requirement, 12 factor requirement. Now you will find that besides 12 factor, which are standard for the cloud native implementation, there is something called X factor. And so cloud native 12 factor we already covered earlier, and it's available on the https 12factor.net. You can refer to that. The X factor, the difference between the 12 factor and the X factor, which is provided by CNF, is that there is a difference in that. So what is similarity between XCNF and 12 factor is that you use declarative presentation of all the software, hardware, and all the project. You have a clean contract in the sense you have proper interfaces and portability is maintained. You have suitable deployment on a modern cloud. Modern cloud means all usually the public clouds like Google Cloud, the Amazon, AWS, and Azure. These are the public cloud, as well as private clouds like OpenStack, etc. And service providers implement one of those, and our enterprises use one of them. So there should be vendor to vendor differences should be minimized, and not only that, here minimizing the divergence between CI/CD, as we said. That means each may have different CI/CD, but they are functionally similar. And scale up with the architecture is important. That is the 12 factor, which is similar with CNF, X factor. But XCNF has got differences in the sense that here you not only talk about the workload, but you talk about the workload or payload types, like what kind of function chaining you are going to use, like whether you are going to use, because network is the key. CNI is a networking interfacing is a key thing, and therefore the protocols are important. So payload type is recognized as Ethernet, IP, MPLS, VXLAN. So these are the things which are used. And additionally, you can see that mechanisms that are supported for optimization or acceleration, like styrategy and memory interface and RAM disk, and those are the various things. Plus, we have got Linux Foundation as some of the projects like DPP, which are at the Linux level, kernel level, and then OVS is for the OpenFlow and for the Open Virtual Switches, which is one of the main themes for Linux Foundation to support the mechanism for Linux interfaces. And the third one is obviously we want everything to be microservices. So you have to disaggregate everything, whether it is database, whether it's a queue, memory cache, all this to be orchestrated and managed through network interfaces. So when we talk about the cloud native, we have to understand that not only the 12 factor, the 3 X factors which are mentioned here are also part of the Nephio to support, to leverage. So Nephio is going to obviously leverage this for 5G use cases. Now 5G, if you look at the service-based architecture, you have got the 3 main important functions: the access management function, the session management function, as you see, and the user plane function. So this is in the control plane, this is in the user plane. User plane is aggregated. That means if you have a user equipment, a mobile phone or a tablet or whatever, you connect to the radio access network through the access management function, where you get the functions authenticated and then followed by the RAN being passing on, the connecting the UE to the data network or to the application where a package tunnel is established, and it is at the layer 2 and then passes on to the layer 3 and on to the full stack, so that session can be managed. Session is at the layer 5. So session management function is what we are looking for Nephio. It's a network function. It includes several discrete functions. So one of them is like service registration, service discovery, onboarding of CNF, sessions create, update, delete, which is the standard code, and IP access management. So you will find that there are, at least even with simple section management function, I can identify 1, 2, 3, 4, 5 microservices. So these are 5 services. If you say that the session management function is the use case, then we have to deal with these 5 use cases, and that will be not only be the control plane side of it, also for the user plane side of it. So here what I have mentioned is mainly on the control plane side. Of course, when you create the session, you create the packet or PDU packet data unit, which needs to be end-to-end from user equipment to the application function or to the data network, depending upon, or you need to use if it is a voice call or something. So Nephio use cases which we are going to address is session management function, and we are trying to tie it with the coupon stack and see how we can enable the Nephio for the 5G SMF use case. And this is in the same thing. I can show you example. This is a one of the examples where you can see the details here. So you can talk to GNB, and this is when you say GNB, it is a G node B. E node B is for the 4G, and GNB is for the 5G. And so UE talks over the interfaces N6 to GNB and talks to the access management function. UE N1 access management function is a part of the what you call authentication services, and it talks here and gets the NSSF to get the slice that is needed and allocated, and which can be used over the UPF after creating the session, the PDU session. SMF generally provides the IPAM or the IP address. So in the service-based architecture of next generation application protocol, there are non-access stratum, that is all these calls to get the clearance of the access and validate, that is subscriber validation coming from the user UDM and all that. That's a part of the non-access stratum. Once you have established connection, then you can go on and establish the data network and connect with the so session management function here it is describing through a service-based architecture. The earlier one what we saw was mainly a what you call standard design from 3GPP. This is nothing but a deployment and how they are deploying it, and we can look at the flow also. So this is the flow. UE establishes a session, and that establishing of requires service registration and creation of the service. So if you have the service which is already registered, then you discover it, and once you discover it, the session management function kicks in. It establishes the PDU session, and then it creates the session and allocates to the UE the IP, and the IP can handle. So our goal in this case is to follow the SMF 3BBTS 23502, which is the standard, and we will try to see how we can engage with the Nephio team, and along with the coupon stack, we will try to create the CRDs that are necessary. And you can see that Nephio is intent based. So what it means is you always have a design studio, so build, deploy, and then control loop to state management, that is. So what we have is, we design the example, if you want to do session management function, then we'll have to design what does it include, what packages it should include, how do we ensure that it is following the policy of the resources, etc. And once we select the cluster where we want to deploy those packages for the session management, we can select those and deliver the package, and once it is delivered, it will be deployed, and once it is deployed, then you have to follow up whether the desired state is achieved. If not, then how do you get the loop back and try to find the metrics and ensure that it is managing to a desired state, which is what it should be always. So you can see that this can be deployed on any cloud. It could be a Google cloud, it could be Amazon, it could be OpenStack, it could be anything. So depending on wherever you deploy, but the bottom line is it is on Kubernetes. So we can say if it is OpenStack, it will be OpenStack over Kubernetes. So Kubernetes is the infrastructure at the bottom where we will be implementing. All are going to be microservices. So example which I described was session management function. So we'll have to do all the 5 microservices or 6 microservices, and make sure that we create packages and ingest that into the deployment platform, which could be OpenStack, or it could be any of the Kubernetes distros. And that will be overlay, and on that overlay, once we do the intent-based delivery, then we do the reconciliation and allocate resources and ensure that it is reliable and continuous. So this is the intent-based deployment for the Kubernetes for the Nephio. So Nephio here exactly means it's a extension of Kubernetes. So normally Kubernetes controller, so if you use OpenStack, we have a Kubernetes controller. Or if you use, let's say, Red Hat Enterprise Edition, as we said, that could be one of the, what you call the Kubernetes underlay or the Kubernetes cluster. Once there is a source, master is always the system and target is the where the deployments is. So all our AMF, SMF in this case, all the components of 5G will be deployed on the target cluster. The target cluster being in this case, what we have, let's say one of the Kubernetes, this one, target clusters, then those target clusters naming will decide how the 5G Nephio will be used, because at the top of it you've got the SMO, they call it. SMO is nothing but a replacement of MANO. MANO is management and network orchestration, and SMO is service management orchestration. So part of the ORAN, you have the SMO which is driving. So you can see that end-to-end service orchestration and slice management comes through the SMO, which is the service management orchestration, or so-called MANO in the earlier days. And that is what has an open API which will be talking to Nephio at the northbound. And Nephio, what it does is it will take the Kubernetes cluster and Kubernetes and create operators which will enable the lifecycle management for the Kubernetes cluster itself, the target cluster I mean, and that will be one of the extension, and we call it as O2. The radio ORAN has got multiple interfaces. We call it as O2 management, and O1 is for the YAML model based CRDs, whereas O2 is for deployment. So we will be focused mainly on these two. One for the Anuket HC, that is the one which we can deploy the OpenStack. So that is the management of the underlay, cloud infrastructure resources and all that. It could include switches, routers. It could include the stack itself for the Kubernetes for the target cluster, so that the pods can be created and recreated, and microservices for that can be maintained, which could be like if it was OpenStack, then like we saw OpenStack microservices, similar thing. And on the operator side, we have the network function itself. So if I talk about network function being a 5G session management function, then those microservices like IPAM, the service registration, and those kinds of operators will have to be done by using a CRD. CRD means you have to have custom resource. That means you have to have a descriptor which describes. And descriptor has got two important, any Kubernetes descriptor if you take, it has two important things. One is the specs and other is the status. Specs usually provides the specification of all the things, including the namespace, the various labels associated, and notations, and most of it, which is like if it is a configuration, etc., are hidden. Most of it is hidden so that people do not know what exactly it contains, but one has to know as a custom resource descriptor extender, the specs, standard specs won't do. So for session management, what do I need to do? Oh, I need to have IP address, so I have to put an IP address there. Does it get from DHCP? Okay, so it is DHCP driven. Then I have to point out where is the DHCP. So all this is part of the specs. So specs needs extension, and that is what once the specs is extended, standard Kubernetes cannot handle it. It has to be handled by a custom resource operator, and therefore we call it as a external custom resource operator to enable those specs items which are added newly. And obviously, if you create new server like IPAM service, then we need to know what is the status. Is it running? Every health check has to be done. So accordingly, the infra has to handle that. So some of the things will be infra based, some will be NFV based. So NFV is nothing but network function is containerized function, not the virtualized in the sense of virtual, but container virtual. because VNF we still use the term commonly. It can be used for workload configuration as well as for automation. So our focus here, we would put it that we definitely are more focused on O1, not 3GPP at this stage, but 3GPP will bring the specs, because in default specs, everything that 3GPP claims may not be possible, and anyway deployers have the option. They can follow the standard, yet they can differ from it in deployment. That's the goal. So this is the crux of what is there in Nephio. And you can see here we have extension to the Kubernetes API. So you can see that there is a Nephio is a whole of extension on the Kubernetes API in terms of infrastructure loop and intent-based deployment of NFV, our network function. And network function virtualization means NF containerization in our case. And the various package management and config management, you can use a config map to map it, but at the same time to automate, you better put it into upstream GitOps type of operation, so that one can, and they have got the various development plans, and we are in the early stage of it, but we want to be able to participate as part of the RCDU OIP lab as well as from the eOTF. And I think I will leave you with all these details. The slides will be available, and if you have any question, you can pass on. And I think I will end my this with next being on the line for session management. Sorry, for the CTO, that is connecting the unconnected. Thank you very much. And next I will invite Vipin and Shubham. Please take over. If you need your slides, or I can show whichever you want to do. How do you want to go about it? Let me stop recording here.